Hello students, how are you all? Welcome back to Akshar ID Foundation classes. So I am your chemistry faculty S. Mohan. So we are doing now 9th class and chemistry ID Foundation. And our topic is thermodynamics. So students, here in the previous classes we were discussing about the thermodynamics and we completed the second synopsis in which we discussed about the enthalpy and how the enthalpy change in the enthalpy during the exothermic reactions and endothermic reactions we discussed. So we completed the synopsis 2 in the previous sessions, right? Today let's start the third synopsis of thermodynamics. Okay, so now let's see. So once again we come to the enthalpy. Just we revise. If you have a material, open the material. Let's see the enthalpy. What's the enthalpy? So students, here how can you define the enthalpy? The amount of energy that is stored in the system. Here system is what? Any substance what we are taking for experimental purpose is called as a system. So the energy stored in the system means the energy stored in the substance, okay, that is available for the conversion into heat is called enthalpy. This already we discussed, right? Enthalpy is denoted by H, that also we discussed, and H is equal to U plus PV according to first law of thermodynamics that we discussed in the previous class. Okay. Now when you see the enthalpy, the word is nothing but the energy or heat stored in the substance. And simply we say that enthalpy means what? The heat stored in the substance. So the word is taken from the Greek word enthalpy. Okay, N means what? Enthalpy means heat. So now the heat is taken, the amount of heat that is stored in the substance is called the enthalpy, right? Or the energy is stored. Now here some characteristics, if you see, enthalpy is a extensive property. What is the extensive property? The property that is depends on the substance amount. Okay, so as the amount increases, the enthalpy also increases. The amount of the substance increases, enthalpy also increases, that we studied. And this is the state property. State property means what? Here there are some state variables, we discussed that. So generally here state variables are what? Like pressure, volume, temperature, right? So if there is an enthalpy of one substance at the pressure P1, volume V1 and temperature T1, then if these state variables changes, like pressure changes from P1 to P2, volume changes to V1 to V2, then temperature changes to T1 to T2, then the enthalpy also changes, right? So that already we discussed in the previous class only, right? If you have material, once you open the students page number 101, so here this already we discussed, but once again it is given in your material. So see page number 101, the definition. The enthalpy is defined as the amount of energy stored within the substance or the system that is available for conversion into heat is called heat content or enthalpy. And according to first law of thermodynamics, already we discussed that H is equal to U plus PV. Yes, H is equals to, enthalpy is denoted by H is equal to U plus PV. Okay. So what is U here? Internal energy, and PV is what? Pressure and volume, the product of pressure and volume. Right. So enthalpy word is taken from the enthalpy. So N means what? Enthalpy means what? Heat. So the amount of heat that present inside the substance is called, and previously it was called as a heat content, but now it is calling as a enthalpy. But the name is changed from heat content to enthalpy, but the heat content was denoted by H. The symbol is not changed. Here also enthalpy is represented by H only. Right. Next characteristics you see here. Just now I told you that enthalpy is an extensive property. The meaning of extensive property is what? Here it is depends on the amount of substance. How much amount of substance is there? If the amount of substance is more, the enthalpy is also more. If the amount of substance is less, enthalpy is also less. And enthalpy is a state property. State property means what? It depends on some variables, state variables like pressure, volume, temperature. If these three changes, okay, then what happens? The enthalpy also changes, right? So that is there. And enthalpy does not depend on the path. So also already this also we discussed in the previous class only. So like for example, if enthalpy is going like, okay, P1 V1 to P1 V1 T1 to P2 V2 T2. So in which path it's moving, that's not depend. But overall, what is the change in the enthalpy? Means what? Towards the final enthalpy means final heat content minus initial content is gives the enthalpy, but in which path it's moving, that we don't consider. Okay, that's all we discussed, students, in the last class only, but here once again they are given here. So that's what we are revising here. Okay, so here our new topic is what? The heat capacity. Yeah, this is important topic. Now let us see what is meant by the sorry, heat capacity. So the heat capacity means what? The amount of heat required, to raise the temperature of a substance, by 1 degree. The meaning is what? For example, if we have some material, okay, so for example, I am taking this vessel, and in some content is there, some substance is there, and then let the temperature is T1 degree Celsius. Now I want to raise the temperature just by 1 degree, means what? T1 plus 1 degree. So to increase 1 degree Celsius, then what do I need to do? I need to heat it. Yes or no? To raise the temperature, we have to heat it. So how much heat is required? The amount of heat required. The amount of heat required to raise the temperature of any substance by 1 degree is called heat capacity. So see, students, here definition: the quantity of heat needed, to cause unit rise in the temperature. Unit means what? 1. Unit means what? 1. Rise in the temperature of a substance is called its heat capacity. And heat capacity is denoted by the letter C. And the formula what we can write here: heat capacity. Okay, that is C is equal to amount of heat needed to raise by 1 degree temperature. Okay, to increase in temperature. Okay, so here heat capacity is denoted by what? C, and heat, the quantity, is denoted by Q, and increase the temperature, so difference in the temperature, that is denoted by delta T. So this is the formula for heat content, right? And what are these SI units? SI unit. Heat is measured in joules, time is measured in seconds. So what do we can write? Joule per second is its SI unit. So that's called heat capacity. Understood heat capacity? Heat capacity means what? The amount of heat or the quantity of heat required to raise the temperature of a substance by unit. Unit means what here? 1 degree. It may be Kelvin, it may be Celsius, whatever it may be, to 1 degree Celsius, okay, or Kelvin is called heat capacity. So heat capacity is nothing but the amount of heat needed. So heat needed, for what purpose we are using the heat? To increase the temperature by 1 unit, okay. So increase in the temperature, and heat capacity is denoted by what? C. Heat needed is denoted by Q, and increase in the temperature is denoted by delta T. What are its SI units? So SI units of heat capacity is Q. Q means what? Heat. Heat is measured in what? Joules. Okay. This already you might have learnt in your school level also, like in the work energy. Yes. So it is measured in joules, and by delta T means nothing but a time. Time is measured in seconds. So the unit is what? Joules per second is the SI unit. Okay. So sorry, temperature is measured in Kelvin. Shit. It's temperature, it's not time. So that is Kelvin. So that is not but a joules per Kelvin. Sorry. Okay. So T stands, it's gone into time. So that's actually temperature. Temperature is measured in Kelvin. The SI unit of the temperature is what? Kelvin. Okay. So that is joules per Kelvin. Right. So see students, now here the quantity of heat needed to cause unit rise in temperature of the substance is called the heat capacity. It is denoted by the symbol C and is defined as heat capacity is equal to heat needed by, means for what purpose? To increase the temperature. Okay. Increase the temperature. So C is equal to, write Q by T, and Q is the quantity of heat. It is measured in joules, and T is the temperature. Temperature is measured in terms of Kelvin. The unit of temperature is Kelvin. So joules per Kelvin. Alright. So that is about the heat capacity. Now next one is here molar heat capacity. Very simple now. Heat capacity, molar heat capacity. So you know that generally in the chemistry, the SI unit to measure the amount of substance is moles. Yes, already we discussed somewhere. Okay. So even in solutions also we discuss moles. Okay. Number of moles. Number of moles is what? It's a unit to measure the quantity of the substance. That's called mole. So here molar heat capacity means what? Same definition. The amount of heat required. The amount of heat required to raise the temperature by 1 degree. To raise the temperature by 1 unit of what? Of 1 mole of substance. What is molar heat capacity? Heat capacity definition, if you remember, if you understand, then you can define the molar heat capacity. So heat capacity is what? The amount of heat required to raise the temperature of a substance by 1 unit, right? So molar heat means what? The same. The quantity of heat needed unit rise in temperature of 1 mole of substance. Just the same, just you add mole there. Just add mole. So that's called molar heat capacity. Okay. So how can you define the molar heat capacity? The amount of heat required or the quantity, any you can write the amount of heat required or heat needed, anything you can write, to rise the temperature of 1 mole. This is very important here. 1 mole of substance. This is very important. Through 1 degree Celsius or Kelvin. So SI unit is Kelvin. So write Kelvin right here. So there's a definition is what? The amount of heat required to raise the temperature of 1 mole of substance, okay, through 1 degree Kelvin. So see now, it's a quantity of heat needed to rise, unit rise in temperature of 1 mole substance is called molar heat capacity, and it is denoted by Cm. Okay, so heat capacity is denoted by C, but here it is what? Molar heat capacity, C, but just we put the M, and formula is what? Molar heat capacity is equal to heat capacity of the substance by amount of substance. So heat capacity of the substance, molar, just I write Cm. So Cm is equal to what? C by N. That is what? Number of moles. Number of moles is denoted by what? N. This already we discussed in the solutions, right? So that's about the this one, and its unit of molar heat capacity. Unit becomes what? C. So what are the C units? Okay, C unit is what? Joules per Kelvin. Okay, so write here joules per Kelvin divided by mole. Okay, that is equal to what? Joules per Kelvin per mole. This is the SI unit of the molar heat capacity. So check students there. The heat capacity is expressed in joules per Kelvin. Joules per Kelvin. This one, and the amount of amount is expressed in moles. So in the chemistry, generally the amount of substance is measured in terms of mole. So therefore, molar heat capacity is expressed as joule per Kelvin per mole. Okay, so that is the unit. So pronounced as joules per Kelvin per mole. So that's about the molar heat capacity. So heat capacity, molar heat capacity. Okay, just difference you see. Molar heat capacity means what? The amount, same definition. The amount of heat required to raise the temperature of substance. Of a substance, how much is not given. So of a substance through 1 degree Celsius. Molar heat capacity means what? Here also the amount of heat required to raise the temperature by 1 degree of which substance? 1 mole of substance. 1 mole of substance. That's called molar heat capacity. Clear? Next here, specific heat capacity. Again the same question here. Okay. So here the same thing here also. Specific heat capacity now. See, here again the word is this heat capacity only, but here the word prefix what is joined here? Specific. What is with the specific? Particular. Specific means what? Particular. Okay. So definition remains the same, students. Definition remains same. What is that? The quantity of heat required to raise the temperature through 1 degree. Okay, of unit mass of the substance. Specific is there no? So for what we have to write a unit mass of the substance means what? Particular mass of the substance. We have some particular amount of unit mass, or 1 kg you can take, so or 1 gram, so unit mass of a substance. Now for that particular substance, what is the amount of heat is required to raise the temperature by 1 Kelvin or 1 degree is called specific heat capacity. So see now, it is defined as the quantity of heat needed, same definition, the quantity of heat needed to cause unit rise in temperature, same, for what? Of a unit mass of a substance. These differences are very important here. Heat capacity, molar heat capacity and a specific heat capacity. All looks like similar, but there is a small difference is there. Heat capacity to raise the temperature of 1 degree of a substance. Molar, 1 degree the heat required to raise the temperature of 1 degree of 1 mole of substance. Specific heat capacity, the amount of same heat required to raise the temperature of unit mass of the substance. Okay, unit mass of a substance. So this is called specific heat capacity. Okay, and specific heat capacity, what we can write as here. Here heat capacity is joules per Kelvin. This is constant. But when you are added mole, molar specific molar heat constantly. So here what we are doing, just we are dividing with the mole. Yes or no? So here what we are doing, specific heat capacity. In the specific heat capacity, what we do is the same thing, we write okay, C by M means mass. Okay, heat capacity is what, joules per second, and mass is measured in what, grams. If this gram is going there, joules per second, sorry, joules per Kelvin. Joules per Kelvin per gram. This is the specific heat capacity unit. Okay, so heat capacity unit is what, joules per Kelvin. But here what specific means what, per unit mass. And how the mass is measured? In grams. So what you can write, joules per Kelvin by gram. And this gram when you make is a numerator, then it becomes to the power of -1. So therefore, the specific heat capacity SI unit is joules per Kelvin per gram. Okay, so that is about the this one. So see here now, specific heat capacity. It is defined as a quantity of heat needed to cause unit rise in the temperature of unit mass of the substance, and specific heat capacity is denoted by small s or small c also we can use, and it is expressed in joules per Kelvin per gram. Okay, so this is about the specific heat capacity. Clear to you? Okay, now specific heat capacity, all right. So we can write, how can we write the formula? So formula we can write here, see now. Here by using, here you can see a J, okay, this K to the power of -1, if you bring here it becomes what, K, and this becomes G. Here K is what, Kelvin, means temperature, G is what, grams, that is mass, and J is what, heat, that is represented with the Q. So S is equal to Q by M delta T. Is this clear to you? If not, once again I'll explain. See here. Here from unit we are taking this one. See now. So otherwise you can take like this. The amount of heat required. The amount of heat required. So heat is denoted by which letter? Q. For what purpose? To raise the temperature. Okay. So delta T. Of how much substance? Of 1 gram. So that is what? Mass. So this is called specific heat capacity, and the formula is S is equal to Q by M delta T. Clear or not this one? Say, by reading the definition, by seeing the definition, you can write the formula. The amount of heat required. Heat is denoted by Q. For what purpose? To raise the temperature by 1 degree. So, temperature. Of what? Of 1 gram unit mass of a substance. So this is mass, right? So Q by M delta T is a formula of a specific heat capacity. Clear to you? So once you check now, so Q is equal to MS into delta T, or S is equal to M, S is equal to Q by M delta T. Here Q stands for amount of heat, okay, and M stands for mass, and T stands for difference. Delta is the symbol is the delta. Del temperature is nothing but a difference in the temperature. Clear, students? So this is about the heat capacity. Now we have come to the very important topic, that is heat capacity at a constant volume and a constant pressure. Okay. So the next topic is heat capacity at constant volume and constant pressure. Okay. So see students, here it is very simple, but little you need to understand some concept. So here heat capacity of constant volume and constant pressure. Heat capacity at constant volume is denoted by CV. Heat capacity is denoted by C at constant volume is denoted by CV. Heat capacity at constant pressure is denoted by Cp. Okay. So, as you are in the 9th class, I am not going to derive this one, the total derivation, but I will explain the concept. So, listen carefully the concept. Okay. So, here, for example, see students, here I have one cylinder, this is a cylinder, and here it is a piston, this is a piston, okay, and here it is some gas, this is a gas, right. What is its volume here? Volume is V. Let imagine the volume is V, okay. Now we are heating, heat capacity means what? The amount of heat required to raise the temperature by 1 degree, okay. So now we are heating this one, heating. On heating what happens? The temperature increases, right. On increasing the temperature, you know that gases expands on heating. Gases expands on heating. You know this one, okay. This I think you might have already studied in the lower classes that heat on heating substances get expands like solids, liquids and gases. So gas also expand, right. So here when we are heating, the temperature is increasing, means what? Internal energy is increasing of that gas, and actually it should expand, but what we are doing, we are maintaining the constant volume, means what? We fixed it, that gas should not expand. We are applying the pressure on the piston, so do not increase the pressure, right. So the meaning is what? Here whatever the heat we are providing, that heat is utilized to increase its internal energy only, not for other purpose like work. How? So see here, one more simple, see observe carefully this one also. Here for example, here this is a piston, sorry this is a cylinder, inside I am taking certain amount of gas, and here arrange the piston, okay, and this is a piston, and I am heating now. And I am heating, and what I am heating? At constant pressure, students, constant pressure. So here constant pressure when I am heating here, okay, so what happens here? Constant pressure means what? Pressure should be constant, pressure should not change. Volume may change, volume may be changes, okay, volume changes, but pressure will not change, right. So here, so this is a gas, and here I am heating, initial temperature is T1, okay, we are providing the heat, certain amount of heat. So what happens? Here the temperature will be increases, am I audible? Right. So the temperature increases, and temperature increasing what happens? The internal energy also increases, but here we are maintaining the constant pressure, pressure should be maintained constant. So the pressure is maintained constant, there will be change in the volume. So what happens? On heating, gases get expands, on heating gas get expands, so that expand means what? This piston is moving up, the piston is moving up, okay, because the gas is expanding, because the gas is expanding, right, the gas is expanding, right. So here the piston is moved up, means what? Some force is applied to displace the piston from here to here. So the force applied to displace an object is called what? Work done, yes or no? So that's called work done. So here on heating, first what's happening? The internal energy is increasing, that is delta U, and also, okay, the piston is moving up because you are maintaining the constant pressure. So there what happens? The work is done on the system. So this is the heat capacity here at constant pressure. So this is a Cp. Cp is equal to delta U plus W, like this you can write. W is what? The amount of work done, right. Now in the other, this what happens, what I said here, here also we are taking the gas, same amount of gas, and we are heating. but we are maintaining what? A constant volume. So, what we are providing the heat, that first the heat is going to the gas, so that internal energy is increasing, but volume, constant volume is what? We have to maintain the constant volume. We are applying some force and we are not allowing to move the piston up. So, whatever the heat we are providing, that heat is only utilized to increase the internal energy, but no work is done here. But no work is done. So, the meaning is what here? CV is equal to only the internal energy is increasing. Clear to you? Only internal energy is increasing. Now, what is the heat kept provided here and here? If you check, then where the amount of heat is more, here the amount of heat is more. Why? Because here the amount of heat is more. Why? Because your internal energy is increasing. At the same time, the gas is expanding. So, due to that, some work is done. So, to do work, to lift the piston, some amount of heat is utilized. So, a delta U plus W. But here the constant volume means what? Only heat is utilized to increase the delta U. Is this clear to you? So, the meaning is what? Cp is greater than Cv. Cp is greater than Cv. Okay. And when you subtract this Cv from Cp, then it was observed that that is equal to gas constant. That is equal to what? Gas constant. So, Cp minus Cv is equal to R. Okay. So, that's all students here. So, with this we stop the class today. So, this is our last topic, relation between the Cp and Cv. So, Cp minus Cv is equal to R. That is the relation between this one. Okay. So, with this we stop our class, and if